All right, next one. Now I look at this and I can see right away that there's been a shift up, right? It's not on the x-axis. So let's start with that midline. Here's your max y. Here's your min y. It's going to be 3 plus 1 over 2. Now, given that I can calculate a k equals 2, some of you can probably look at it and say, oh, that's the middle of the graph right there. I can see that the maximums and minimums are the same distance away from that line. That is perfectly okay. You do not have to use the formula to calculate k. Okay, let's see, is it sine or cosine? Well, here's the midline, and here's the x-axis. It is not on the midline, it's above the midline, which means it's a cosine graph. Okay, let's do the amplitude. 3 minus 1 this time. Looks like the amplitude is 1. Now we're going to say, is it reflected? No. Again, it's the same. It's still got a max. So my A equals 1. Okay, let's go with period. So 1 cycle. Whoops. That's not pretty. It's going to erase my midline, but that's okay. Oh, it did it good. Yay. Okay, 1 cycle looks like this. Stops back up here at the maximum. And it looks like it's at pi again. So our period equals pi. We've got to solve our equation for b. 2 pi over p again. Looks like it's exactly the same. Okay, b equals 2. That means our equation is going to be y equals a, which is 1. We can leave it off, times the cosine of b, x. Now we do have a k, so we've got to add that vertical shift, that k, onto the end of it. So just to make sure, a was 1, b was 2, and k was 2, just so you remember where each piece went. Okay, let's try some applicational problems. This one is mass attached to a spring is pulled toward the floor so that its height above the floor, so that's what we're measuring, is height above the floor. Oops. So height above the floor. So it's attached to a spring is pulled toward the floor so that its height is 10 millimeters. Okay, the mass is then released and starts moving up and down, reaching maximum, minimum of 20 and 10 meters, respectively, with a cycle of 0.8 seconds. So obviously important key pieces in there. Hopefully as you heard that or read through it, some words started sticking out to you, in particular maximum and minimum, and here at the end this word cycle. Okay, it says assume that the height h of t of the mass is a sinusoidal function, meaning it's either sine or cosine, where t is the time in seconds. It says to sketch a graph of h from t equals 0 to t equals 0.8. T equals 0 is the time at which the mass is released. Okay, first of all, the fact that it mentions a cycle, that's talking about a period. So when it says to sketch a graph of it from 0 to 8, it's saying just graph 1 cycle of this function. T is the time that it was released. So visually, let's talk about what's happening. So this spring is being pulled down. See how the spring is kind of expanded out to where it's pulled out to where right here is 10 millimeters from the floor, right? 10 millimeters from the floor. And then it's released and it bounces up and bounces down and keeps bouncing up and down. But the maximum it reaches, let's say this is this one, is 20 meters. So it gets pulled down, released, it bounces back up, keeps bouncing, and the highest it ever reaches back up is 20 meters, which is off of the first pull, I'm pretty sure. It starts here, so this right here is where t equals 0. So if we look at a graph of this, kind of a little easy cheater graph, right? We've got t equals 0, and our period ends at 0.8. So I'm going to go out 1, 2, 3, 4, and I'm going to put 0.8. Now we've got to figure out what to count by. That's your p. So p over 4, that's 0.8 over 4, or 0.2. So right here, 0.2, 0.4, 0.6. Then we've got to count up here. Now it says the highest it goes is 20. The lowest it goes is 10, but I'm going to count in 5s, 5, 10, 15, 20, right? So 5, 10, 15, and 20. Okay, let's talk about some of the points on here. It says T is the time at which the mass is released. And then it says up here, it's released when its height is 10 millimeters. So at time equals 0, its height, that's what this guy represents. This is the height, and this is the time in seconds. Okay, so it's released right there. Then they let go, and it goes back and forth, and the highest it reaches is 20. So thinking about this as a sinusoidal graph, knowing that it goes up to 20, and then it's going to come back down to 10 and go all those other different values in between. Then at the end, it should end up back around 10. In the middle, it's going to be up here at 20. And then in between are going to be the middle values. This is just estimates. We don't really know enough for it to go that way. So what it actually looks like is a cosine graph. Okay, so like I was saying, it looks to me like it's a cosine graph. If it did not start at 0 at time 0, it started at 10, and then as time passes, it goes up higher, reaches its maximum, and also comes back down to its minimum, sorry, that means it's going to look like that shape of a graph. It is not going to be a sine because it comes up halfway through, reaches the maximum. Anyways, so the next one says to find an actual graph for it. So regular old cosine function looks like this. I'm not going to put, well, I'll put it in there just to stay consistent. Bx minus c plus d. Okay, so we need to figure out some pieces. I like to do it from the graph, but remember that there are those formulas for the max, the min, and all that stuff. I can see by looking at it that these are where my intercepts normally would be, so that's going to be my midline, which means D right here, my midline, since it moved up, it's going to be at y equals 15. And then I can also see from the graph that the distance from the midline and the top, and from the midline and the bottom, the minimum, is 5. So that means my amplitude. Now the other pieces I need are the b and the x. Now the b relates directly to the period, but this guy right here, c, is some kind of phase shift. But there's no phase shift. We started at a value on the y-axis as its maximum, but it was reflected, so it's actually a minimum. Since there's no phase shift, we don't need to worry about this guy right here at all. All right, next one is where it gets a little bit weirder. We need to find b right here. So normally the formula for period is 2 pi over b. but we need to calculate b, and we have our period. It told us that one cycle was in between 0 to 0.8, right? That's how I need to graph these numbers right here. So my period is 0.8. So what I would have done was I would have took 2 pi divided by whatever this b was, and that would have equaled 0.8. I could finish solving for b. You can, cross multiply and finish dividing. But here's the coolest thing. This formula, the b and the p are interchangeable. You can literally switch p and b and it will be the same type of formula. So I don't need to solve anything. I would just take 2 pi divided by 0.8. Now I would take the 2 divided by 0.8 and then put pi on the answer. So it would be, if you take 2 divided by 0.8, that becomes 2.5 pi. But if you can, if it's possible, I prefer it as a fraction with pi in there. If you did a decimal to 2.5 pi, that's okay too. I just prefer fractions when it's there. Doesn't matter though. Okay, so we've got our a, b, and d. So we can write out our formula for our function. It would be h of t, because that's what they told us to write it in terms of, equals a, which was 5, times the cosine of b, which is 5 pi over 2, x plus 15. So 5 cosine pi halves x, you can put these in parentheses if it helps you see it, plus the midline, which was the 15. And that's your formula for it.